Hello, everyone. Welcome back. I hope you're doing great and ready for the next problem. Now, let's work on type 6 of the important exam questions from chapter 1. Two identical ions are separated by a very small distance, and the electrostatic force between them is given. We need to find the charge of each ion and then determine how many electrons are missing. Since the ions are identical, both charges are equal. So we write Coulomb's law as F equals kq squared over r squared. And as you definitely know, the important constant K is equal to 9 times 10 to the power 9 Newton meter squared per Coulomb squared. Now we solve for Q by taking the square root of Fr squared over K. After substitution, we get the charge of each ion equal to 3.2 times 10 to the power negative 19 coulombs. Next, to find the number of missing electrons, we divide this charge by the elementary charge. That gives us 2 electrons missing from each ion. Excellent job. Let's continue to the next important exam type. Now let's solve type 7 of the important exam questions from chapter 1. We have 2 equal charges placed symmetrically on the y-axis and a third charge moving along the x-axis. We need to determine where the force on particle 3 becomes minimum and maximum. Step 1. Because particles 1 and 2 are identical and equally spaced, the forces they produce have equal magnitudes. Their vertical components cancel each other, while their horizontal components add together. So the net force acts only along the x-axis. Step 2. The distance from particle 3 to either charge is square root of x squared plus d squared. Using Coulomb's law, the force from one particle is k q1 q3 divided by r squared. Step 3. Now we resolve the force into components. The horizontal component equals F cosine theta, and cosine theta equals x over r. So one horizontal component becomes k q1 q3 times x divided by r cubed. Since there are 2 equal horizontal components, we multiply by 2. This gives the net force equation, 2 k q1 q3 x divided by x squared plus d squared to the power 3 over 2. Excellent. In the next step, we will use this equation to find the minimum and maximum values. Now let's continue and find the minimum and maximum force values. Step 4. For the minimum force, we look at the force equation. When x equals 0, the horizontal distance becomes 0, so the net force is 0. Therefore, the minimum force occurs at x equals 0, and its value is 0 newtons. Step 5. Now let's find the maximum force carefully. We take the derivative of the force equation with respect to x, then set it equal to 0. This is the standard method for finding maximum or minimum values in calculus. After simplifying the derivative, we obtain d squared minus 2x squared equals 0. Now solve for x. 2x squared equals d squared. So x squared equals d squared over 2. Taking the square root gives x equals d over root 2. Now substitute d equals 0.170 meters. So x equals 0.120 meters. That is the position where the force becomes maximum. Substituting this value back into the force equation gives the maximum force equal to 4.9 times 10 to the power negative 26 newtons. Excellent work. This problem is a continuation of our previous questions, and it represents type 8 of the important exam questions from chapter 1. And for anyone new here, this channel is all about fast, clear, and exam-focused engineering and physics explanations to help you save time and score better. So if you enjoy this type of content, don't forget to subscribe, like the video, and join us for the next parts. Now let's begin. This is a very popular problem that combines electrostatic force with equilibrium. Two identical charged spheres are suspended by strings, and because of electrostatic repulsion, they move apart until equilibrium is reached. We need to derive the equation for the separation distance x. Step 1. Let's analyze one sphere. There are three forces acting on it: weight downward, tension along the string, and electrostatic force outward. Step 2. Now resolve the forces into components. In the vertical direction, tension cosine theta equals mg. In the horizontal direction, tension sine theta equals the electrostatic force. Dividing the two equations gives tangent theta equals electrostatic force divided by mg. Step 3. Since theta is very small, tangent theta is approximately equal to sine theta. From geometry, sine theta equals x over 2L. Now substitute Coulomb's force, kq squared over x squared. So we obtain x over 2L equals kq squared divided by mg x squared. Step 4. Rearranging the equation gives x cubed equals 2L kq squared over mg. And finally, x equals the cube root of 2L kq squared over mg. Excellent. In the next step, we will substitute the values and calculate the charge magnitude. Now let's continue with the final steps and calculate the charge magnitude. Step 5. First, convert all quantities into SI units. The string length becomes 1.20 meters. The mass becomes 0.010 kilograms. And the separation distance becomes 0.050 meters. Now use the equation we derived earlier. Q equals the square root of mgx cubed divided by 2lk. Substitute all the values carefully into the formula. Step 6. After calculation, we obtain Q equals 2.4 times 10 to the power negative 8 coulombs. Excellent work. Honestly speaking, this chapter has now concluded, and you have completed the most important exam types and key ideas from Chapter 1. If these lessons helped you, don't forget to like the video and stay with us for the next chapter and next parts of the course. See you in the next video.